So this video is going to focus on the answer key to the practice problem worksheet for skeletal structures. And for this one, we're focusing on the charged molecules. One of the previous videos looked at the worksheet for neutral molecules. But this one's going to be looking at how do we determine when an atom has a positive or a negative charge, and how to make sure that we have the right number of electrons for each structure. All right, so let's take a look at this first one. So here we can see that there's this oxygen that has a number of bonds that it does not like. So we know that oxygen wants to have 2, but we have 3 here. And so the first thing we want to do is draw in all the lone pairs to make sure that oxygen has a full octet. And so since it has 3 current bonds, we have 6 electrons from the bonds. So we need 2 more from a lone pair. And so this oxygen will only have 1 lone pair on it. And then if you recall from my lecture video on this topic, you can also use that chart to help guide the number of lone pairs that you should see. All right, so that's for the number of lone pairs. The next thing we have to do is determine the formal charge on the molecule or on the atom. And again, you can use that the table in the lecture video, or we can do this by hand. So oxygen wants 6 electrons. That's how many valence electrons it wants. And then how many it has is 3 from the bonds. So 1 from each bond, plus those 2 lone pairs. And so it has a total of 5. And so it has a net charge of +1. And so the overall charge on that oxygen should be +1. And for these first ones, we're going to ignore all the carbons. We're going to assume all the carbons are fine unless we're given more information. It's very difficult to determine, like we would need either the number of lone pairs or the charge on a carbon to be able to look at it closer. So we'll have a few practice problems later on, but for now, we're just looking at those heteroatoms. So let's take a look at this next one. So here we have the nitrogen. And so we know that nitrogen wants to have 3 bonds. However, here it has 4. And so since it already has 4 bonds, we can't add in any lone pairs because we'd be extending it beyond an octet. And so we're kind of stuck with these 4 bonds. And so there is no lone pairs. And again, that's because that nitrogen already has 4 bonds. And so the next thing that we have to do is determine the formal charge. And so nitrogen wants 5 electrons based off of where it is on the periodic table. And how many does it have? It has 4 single bonds. So it just has the 4 from the bonds plus 0 lone pairs. So it has 4. And if we subtract those out, we get +1. And so this nitrogen also has a positive 1 charge here. All right, let's move on to the next one. So here, let's take a look at this oxygen right here. So here we can see that this oxygen has those 2 bonds that it wants. And so to fill out the octet, we would draw in 2 more lone pairs. And oxygen's happy like this. This is the preferred state of oxygen. Since it wants 6 electrons and it has 2 from the bonds and then 4 from the lone pairs. And so it has a neutral charge. It does not have plus or minus 1. Now let's take a look at this one right here. So the one on the right has only 1 bond. And so to get an octet, we'd have to fill in 3 more lone pairs to make sure that that oxygen has a total of 8 electrons. And so from here, we can calculate the formal charge. So we have that oxygen wants 6 electrons. And then it has 1 from that bond and then 6 from the lone pairs. And so it has a total of 7 and so we end up with 1 or -1. And so the charge on this oxygen is going to be -1. For this one, let's start off with this nitrogen. So similar to the previous one, it has two bonds. It has one right here and then one to the hydrogen. And so to have a full octet, it needs two more lone pairs. And now to calculate the formal charge, nitrogen wants 5. And it has 2 from the bonds and then 4 from the lone pairs. And so it feels like it has 6. And so we end up with -1. And so that charge on that nitrogen is -1. All right, this next example in the middle right here is going to focus on this carbon atom at the end of this alkyne or triple bond. And so here, so carbons, we have to draw in the lone pairs or the positive negative charges to make sure that, to know information about the state of that carbon. Since we don't show hydrogens in skeletal structures, it's impossible to know if the charge is due to a missing hydrogen or if it's actually charging. And so here we can see that this green carbon on the end here has 3 bonds, and then to fulfill that octet, it has a lone pair of electrons. And so we already know that it has that full octet here. So there's nothing else that we need to add in. However, we do have to calculate that formal charge. And so carbon wants a total of 4 electrons, and it has or feels like it has 5 electrons because it has 1 from each of those bonds and then 2 from that lone pair. And so altogether we end up with -1. And so this carbon atom over here has a -1 charge. And it's something that we're going to see really frequently, that anytime that carbon has a lone pair of electrons on it, almost always it's going to be a -1 charge. All right, let's take a look at this next one. So here I specified in the directions here that this carbon over here does not have a full octet. It's something that we're going to see, especially in, it's a very common motif that we'll see in organic chemistry. But here what this means is that this atom right here does not have a hydrogen atom. And that's going to be very, very important because that means that there's available space for something to come in and form a new bond here. And so this carbon only has 6 electrons that are filling its orbitals. And so it has kind of like an open space for additional electrons to come in. And so there's no lone pairs that we need to draw in here. We just essentially don't have a full octet on this carbon. So we're going to leave this one as is. The charge is +1. And again, we know that because we're already given that positive charge. For this next one, this oxygen right here already has 2 bonds, one to the carbon next door and then the hydrogen. So the only thing we should do is draw in those lone pairs on the oxygen. This next oxygen over right here also has 2 bonds already and 2 lone pairs. And so both of these highlighted oxygens are happy as they are. They both have 2 bonds and 2 lone pairs. And so the charge is 0. Now let's take a look at this terminal one right here. And so here we can see that this oxygen only has 1 bond. And so to fulfill that octet, we would want to draw in 3 more lone pairs here. And next we would calculate the charge. So oxygen would want 6 electrons. However, it only has 1 from that bond and then +6 from those lone pairs. And so it ends up with a -1 charge here. All right, let's move on to this middle one. So here, let's start off with this oxygen. Similar to the previous question, we can see that that oxygen already has 2 bonds. So we just add in those 2 lone pairs. And as before, an oxygen is happy when it has two bonds and two lone pairs, so there's no charge on that one. However, on this bottom nitrogen here, this nitrogen has two bonds, but if we recall, a nitrogen wants to have three bonds to be neutral. And so since it doesn't have a full octet, we have to add in two lone pairs here. And so we're going to add in those two lone pairs to that nitrogen. And next we're going to calculate the net charge on that nitrogen. So nitrogen wants 5 electrons. And it has 2 from the bonds and then 4 from the lone pairs. And so if we do 5 minus 6, we get -1. And so this nitrogen has a negative charge. All right, this next one here, this oxygen right here, same thing as before, nothing. It's going to be, we're going to add in those 2 lone pairs, and otherwise it's satisfied, nothing that we need to do. And then we can take a look at this oxygen right here. And so this oxygen we can see already has 3 bonds. It has 1 right here that I highlighted, and then 2 to the 2 hydrogens that are bonded to it. So it has a total of 3 bonds already. And so to get a full octet, we only have to add in 1 lone pair here. And then from here, we can calculate the charge. So oxygen wants 6, and it has 3 from the bonds and then 2 from that lone pair. And so if we do 6 minus 5, we end up with +1 charge on that oxygen. All right, let's take a look at this one. So similar to that previous question, we drew in a lone pair already here. And so in comparison to this previous one, where this carbon already had 3 bonds and a lone pair, so it already had a full octet. In this one, we can only see currently 2 bonds and that lone pair. And so from here, we can imply that we have a hydrogen that's attached to this carbon right here to fulfill that full octet. And we're just not drawing in that hydrogen within the skeletal structure, but it is there. And so carbon in its neutral state wants 4 electrons, and it has 3 from the bonds and then +2 from that lone pair. And so we end up with -1. And again, we have that negative charge. All right, let's take a look at this next one. So let's start off with this nitrogen. So this nitrogen already has 3 bonds. So to fulfill the octet, we would add in 1 lone pair here. And in this state, this is the preferred state of nitrogen where it has 3 bonds and 1 lone pair. So the charge is 0 for that nitrogen. And then this oxygen right here already has 1 bond. And so to get that octet, we would need to add in 3 lone pairs. And then we can calculate the charge. So it wants 6 electrons, and then it has 1 from that bond, and then it has 3 lone pairs. So it has a total of 7. And so we have a -1 charge here. And we can see that the structure is very similar to the one that we saw up here. I'll highlight this in blue. So we can see that this structure right here ends up being very, very similar to this one, where both of them have those 3 lone pairs on an oxygen, and as a result of that have a negative charge. All right, let's do this last one over here. So for this one, this oxygen in the middle, similar to the ones that we've talked about already has 2 bonds. We have 2 lone pairs, net charge of 0. And then this nitrogen right here already has 4 bonds. So we can see 3 methyl groups are attached to it, and then this other carbon bond to a carbon. And so we're not going to add in any lone pairs. However, since this nitrogen doesn't have 3 bonds, it's going to end up having a charge. And so Nitrogen wants 5 electrons, and it has 4 of those bonds and 0 lone pairs. And so if we subtract 5 minus 4, we end up with 1 electron deficient. And so now we have a +1 charge on that nitrogen.